Hi everyone, welcome back to workshop, and it's repair time again. Well, to be a bit more accurate, it might be repair and refurbishment time, because today I've got a Thandar TS3022S dual rail power supply. Now this is a Thandar power supply as opposed to Thirlby Thandar or TTI, which they eventually came after the two companies merged. Now as you'll notice, the power supply is in a bit of a state. We've got the front cover here just peeling off around there. We've got some knobs missing. We've got some odd looking banana sockets there. Some of them not even tight, these ones here. There's a little bit of refurb work to do on the front of the unit. The front panel also needs cleaned up. As you can see, it's just totally grubby and dirty, so I will try and clean that up as well. And the top cover, yes, it could probably do with a paint as well, but in the first instance it is marked down as faulty, so we'll try and get it up and running. Now there is a note on the top of the unit. I'll just let you see that, hopefully. It's not my writing. 2 diodes knackered. So yeah, we'll have to open it up. I can't power it up. We'll open it up, take a look inside and see if we can spot those 2 diodes that's mentioned here. I've got some screws missing on the side. That's for sure. And we've got all different shapes and sizes as well. Wow. So somebody's definitely been in and out of this unit on more than one occasion, I would have thought. Right, should lift off. Well, there's your problem. Let me just shift it round and let you take a look at that. Yeah, we've got a board here with a large cap on it. All the wiring's intact, and as you can see, this is meant to be bolted down onto the bottom of the unit. In fact, the screws are just temporarily put there, and it should be like this one here. So I wonder if the diodes mentioned are bridge rectifier diodes that are on this board. As you can see, you've got 2 large transformers with the bulk cap and bridge rectifiers on 2 small boards mounted on the base of the unit. We've got some large transistors heatsink mounted at the rear of the unit. Yeah, we've got at least 4 of them that I can see, and 2 display panel PCBs. Yep, 2 totally independent channels, totally identical by the looks of it. And then you've got the back of the potentiometers there. So first things first, let's put the meter on these diodes and see if we can find that 2 faulty ones. Ah, 0 volts on that one here. I think that might be the 2 faulty ones there. I think they're dead short. Yeah. Okay, I'll replace that 2 diodes straight away. Well, in actual fact, I'm going to replace all 4, just to be on the safe side. 1N5401s. Yeah, I've got something that will go in there, no problem. Let's take a look at my loose diode bag. One N5404s. They'll do. Higher voltage, but they'll do the job. I don't think I've got 1N5401s. 5400, a little bit lower voltage. Nope, 5404s it is. Okay, so let me go away and change those 4 diodes, and we'll retest them, make sure they're okay in circuit, and I'll also check the other side as well, because it looks like we've got some other diodes at the other side as well, plus some transistors by the looks of it, and some caps. But I'll change those diodes first and then I'll come back. Right, let's just check these diodes out of circuit now. 0.5 volt, that's okay. That one's shorted. 0.5 volt, that's okay. Come on. 0.5 volt, that's okay, and the other way around. Nothing, that's okay. Dead short, that's faulty. That one's okay. And that one's okay. So yeah, just one showing as dead short out of circuit, but I'm going to replace them all. And there we go, there's the 4 new diodes fitted. Now I have raised them off of the PCB a little bit more than they were originally, and that's just to stop the heat transfer, or to minimise it anyway, the heat transfer from the diode body itself down onto the actual PCB. You can see on the other side of the board here, let me just turn it round. You can see on the bottom side there, a slight discolorization round about there. That's the heat of those diodes transferring down onto the PCB. And I've managed to give it a little bit of a clean up using IPA best I can. It's quite stained really, that underside of that PCB. So next thing, let's check the diodes at the other end of the board and some of those other components as well if we can. Right, here we go, 4 more diodes, another bridge rectifier I think. That one's okay. That one's okay. Swap the leads for the other 2. That one's okay. And that one's okay. Oh, bad joint there. Yeah, no problem. So those 4 diodes are okay. That's another bridge rectifier. That'll be another winding off of the transformer, probably for the front panel electronics, smaller diodes. Now there is actually another diode, it's a signal diode, so let me just check that whilst we're here. Yeah, that one's okay. The other 2 components, they're not transistors, they're 2 regulators. We've got a 7.8 LO5 and a 7.9 LO5. That'll be giving the front panel controls a plus and minus 5 volt supply, no doubt. So whilst I'm in here, I'm going to check those 2 large electrolytic capacitors on that small board. And it would be rude not to use the LCR meter that I repaired in my last video. So let's try it out. Let's try and get a good contact there. They're 100 microfarad, so that's looking spot on. And the other one. Yep, good enough for me. Right, with this board checked out, I think it's good enough to be bolted back down. I did check the other capacitors as well as the ESRs, etc. and they're no problem at all, so I'm not going to recap anything. So let's get the screws off of here and bolt it back down. And I did check the big capacitor as well, and it's fine. I thought I'd check the fuse in the back of the unit since those diodes were gone, and yes, it's blown, so I'll go and dig out a 1.6 amp fuse, fit that, and I just noticed that's a 3 amp fuse it's fitted. Yeah, first action in repairing a faulty power supply, increase the fuse size. I don't know. So the question is, why did that diode go dead short? Well, possibly overcurrent, maybe due to a short on one of the output transistors maybe. That would certainly cause a high current on that diodes, or possibly even a transformer problem. So I think we'll just go across the transformer first, just make sure the windings seem intact, and if they look okay, I'll take off the back panel here and expose those transistors, and let's see how they measure up. So as a quick and dirty test, we'll check the transformers first. We've got the primary side at this side, the secondary side at the bottom at the other side, and there's 2 primary windings. They're in series for UK use, 230, 240 volts. So we'll try the first winding here. They are centre tap, but the centre tap's not actually used. So across the first winding, 5.8 ohms, and the centre tap, wow, it's off to one side, 0.76, so we should be getting about 5 at this side. 5.4, yeah, it's probably okay. The next one, 5.3, the unused centre tap, 0.64, and 5. So I think that one's probably okay. Now the other side, the secondary side of the transformers, you can't see. We've got two windings, as I mentioned earlier. We've got a centre tapped winding, and then we've got another standalone winding, which is probably for the front panel electronics. So let me just go down in there. 9 ohms, and the centre tap 4.9, and the other side should be around about the same. 5, yeah. And the other secondary 0.34, a lot lower of a voltage there. And whilst I'm here, I'll just check those windings down to earth as well. I'll just run right along them. Make sure there's no shorts to earth. No, that side's okay. I was reading something for a second there. Uh-oh. Yeah. Way up in the 60 odd mega ohms. That should be okay. That one's okay. That one's okay. 60 odd mega ohms, that'll be okay. Well, I think the transformers are probably okay, so let's remove the back panel here and expose those transistors. And the heat sinks just fall apart. This was the faulty side here, but I'm just taking the cover off of this side here at the same time, just to give it a check whilst we're in here. And maybe a bit of a clean up as well. Look at the dust in there. Oh wow, wow, that is loose. Somebody's been in here before. Interestingly, there's some washers, or there was, on the back of the heatsink there. This is little spacers off of the back panel. I think that's probably to stop the heat dissipation going back into the chassis here, that could end up being transmitted back onto the control board. So just putting a couple of washers there on the four corners just keeps the heat local as much as can be, and I notice they are fitted on here as well. But let me check these other pillars. They're quite slack as well. Maybe they were just slack from the factory. Right, to test these power transistors, they're all 2N3055, all three of them. So I should be able to get a diode test between the base emitter and the base collector. So if I just go ahead and do that now, got a multimeter set up. So base emitter, yep, and base collector, yep, and if I turn them round, I shouldn't get anything. That one's fine. That one's fine. So that transistor's probably okay. So let's try this next one. Base emitter. We're getting way under a volt. And that's because there's a 47 ohm resistor between the base and the emitter there. So we'll ignore this one for the time being. And yet the base collector's fine. So I think probably that transistor's okay. And the one underneath, same thing. That probably be in parallel with that 47 ohm, would it? No, it's not. That's interesting. And the base collector. Yep, I'm getting something there. So this could be connected back on the control board. That green wire. That green wire there on the emitter actually loops back and goes away back to the control board. So yeah, it could be in parallel with the yellow wire here that's on the emitter that goes away back. The only way I'll know that is if I remove that 47 ohm. I think I'll remove it anyway and give it a bit of a tidy up, and I'll show you why. This wire in here is almost wound around the emitter pin. It's really quite untidy there, so I'm going to tidy that up just a little bit, and then maybe we can expose that 47 ohm resistor, take it off, and then retest that other transistor. I'll just snip this tire up. And pull it out. There's that green wire that comes from the other transistor down below, and it just loops away back off, as I mentioned. Right, let me remove that resistor and I'll retest. The wire's off and the resistor removed at one side, so let's just check that base emitter again. Yeah, that's fine now with the resistor removed. And base collector, yeah, that was fine. So down onto the one underneath. I'll try not to. Let's test this one again. Yep. Base emitter, base collector are fine on that too as well. And a quick little test just to make sure these case of these transistors are not shorted out onto the heatsink. And they're not. They're quite rusty, but I'll just leave them well alone. Yep. So I think this side's okay. I was hoping to find something wrong there, but it's not to be. So let me reassemble these heatsinks back onto the back panel. Well, I was just away to offer up the outside heatsink, and look what I spotted. Can you see it? Look at this collector wire here. Wow. It's not even been soldered. It's not ever been soldered for the life of this power supply, or maybe since the transistor was replaced, but it doesn't look like it has. I think that's right from the factory. Never been soldered. Let me go and fix that and get this heatsink back up. Well, there's that side reassembled. A new washers and the screws there, and I've buffed up the head of the screws and the wire brush, make them look a little bit better. I did try and clean up the transistors a little bit, but I've not really stripped them down at all. Actually, they could all do with the new screws and stuff like that, but nah, I'll do not bother with that. It is an old power supply, and it's a sympathetic refurb, I think. So I'll start working on the second side now, and I'll come back when that side's completed. Well, there's the back end back together again. Buffed up screws, new washers, looking a lot better, and hopefully functioning a bit better as well. The next thing I think I'm going to do, I think I'm going to pull the front panel boards there, the control board, just to have a look at it, see what I can see. And one thing I noticed whilst I'm in here, yeah, the attention to detail on the wiring looms leaves a little bit to be desired. Just bunch up the wires and stick a tie wrap around it. Wow. Well, that's one of the control boards out. And one thing I did have to do, there's 4 screws that hold it in. One of the screws is right down there. And the problem is, there's no way you're getting a screwdriver in down there. But very luckily, Thandar thought about that, and they put one hole down here. Let's see if we can expose it. There you go. One hole right down there to get a long screwdriver right through that screw. However, I did have to disassemble the heat sinks again just to get the screwdriver between the 2 plates, really, in order to get right through, get the head of the screwdriver in onto that screw. So there's the front of the control board exposed. I'll be able to do some checks in it. I'm not going to power it up obviously, but at least I'll be able to clean up the face of the LCDs, check the capacitors, check some of the transistors, and check the supply across the ICs is not dead short or anything like that. Okay, well, I've cleaned up the face of the LCDs, they're a lot clearer now, and I've also checked for shorts over the supply to the digital ICs and also the op amps as well. I've checked out this capacitor here, and it's 63 volt, 100 microfarad, still reading 100 microfarad on the meter, so that's okay. And I've also checked out all these transistors in situ, and they all appear to be okay. So I think I can go and mount this board back on the front panel. However, I do want to clean up the front panel first. But before I can do that, I will need to remove some of these banana sockets, some of them are cracked as well I notice, and replace the ones that are damaged and tighten the ones that are slack. So I'll go way off and do that now, and then I will clean up the front panel and probably glue this back down as well. It's peeling away from the front metalwork there. Well, I've replaced that banana socket all nice and tight, but look at the next one. It's missing a nut, and it wasn't me that removed it, so I figure somewhere inside this unit, unless it fell out through the holes in the bottom of the unit, there's a nut lying around. Well, there's the front panel cleaned up. I didn't use IPA, it didn't seem to take much of that ingrained dirt off, so where IPA won't work, the kitchen and bathroom stuff does. And these small clamps here are real handy when you want to glue the front panel back on and hold it till it sets. Okay, I think we're ready for a power up. I've got the control boards just loosely fitted, a couple of screws, and the heat sinks at the back are not entirely tight but tight enough. And yep, let's try a power up. So I'll get this block of rubber underneath it so you can see. And let's switch on power. Okay, power on. So far so good. Let's see if the coarse adjust pot in this channel 1 works. Yep, 0 volts all the way up to 30 volts. It's a 30 volt power supply. And how about channel 2? Yes, 0 volts all the way up to 30 volts and 0 amps displayed. Looking good so far. So let me put my meter on the outputs and check them. Okay. Yep, 16 volts, pretty accurate. How about channel 2? 11.8, yeah, that's accurate enough as well. Let's just try all the way up to 30. Yep, and all the way down to 0. Yep, that's looking good as well. And back to channel 1. Same thing, down to 0. And all the way up to max 30 volts. Yep, that's looking good. Wow. Right, next thing, let's put on a load and let's see what it does under load. Okay, so let's put it to 30 volts. I've got my electronic load hooked up just off camera, so I'm going to give it a half an amp load just to see what it's like initially. And yes, look at that, half an amp, perfect, 30 volts being maintained, no problem. And the electronic load showing 30 volts as well. Let's try channel 2. Let's move this across. Channel 2. Put this up to 30 volts as well. And turn on the electronic load off camera. And yes, half an amp there as well. Right, it's a 2 amp power supply, so let's try it. It is max 30 volt, 2 amp, and see how it responds. Off camera there, just turn it on. Yes, 1.997. Can't get better than that. And how about channel 2? Right, off camera, I'll just turn on the 2 amp load. Yep, 1.996. Now in channel 1 you did see it over range there, and that's because these are 3.5 digit DVMs here, so you're going to only read a maximum of 1999 before it goes over scale. But yep, 2 amps and channel 2's working perfect, and I'm showing 30 volts on the electronic load. Perfect. So what next? Well, I think I can button up all the boards, tighten up the heat sinks at the back, and put the cover on once I've painted it. How about the current limit? Well, I've got channel 2 hooked up, So let me just turn on the electronic load at 2 amp. I've got the current limit set to maximum. So there we go, running at 2 amp, and let me just turn that down, and wow, yes, look at that. And we've got a flashing indicator there to show that we're in current limit mode. So there we're down to 0.5 amp. Perfect. And let me just test channel 1 as well. And let me just pull that down to 30 volts. Yep, and the current limit's at maximum. And as you can see, I've actually put knobs on now, so it's looking a little bit better. So let me just turn on the electronic load. Yep, 2 amps, and adjust it down, and yes, perfect. It's not exactly fine control, but it does seem to work. So there we go, that's all back together again. The cover painted with enamel dark grey paint. I don't think it looks too bad, and I don't think it looks too bad from the front either for an old power supply. So this will be destined for somebody's workbench somewhere, no doubt. It's quite a capable old school 30 volt 2 amp dual rail power supply. So thanks for watching, and remember you can always comment down below, and don't forget to like and subscribe. It really does help the channel grow. And if you've got any faulty test gear yourself that you don't want, then give me an email. Contact details are on my website. There's plenty more repair videos on my channel, from the simple to the complex. Check them out, and thanks for watching.